Good morning, everybody. Today we are going to look at limit of a function. So what do you mean by limit? Consider a function from A R is a subset of R, and consider an arbitrary point C. C may be inside A or may not be, but C is a cluster point. That means C is in the closure of A. For such a point, we say that limit of f of x as x goes to C, where x is not equals to C, exists and is equal to L. Notation: limit of f of x as x goes to C equals to L. If given epsilon greater than 0, there exists a delta that depends on epsilon as well as point C and is positive, such that modulus of f of x minus L, capital L, is less than epsilon whenever modulus of x minus C is less than delta. So this is also known as epsilon delta definition. In other words, whenever x approaches C, does not becoming C, but it comes closer and closer to C, the corresponding functional value f of x would be closer and closer to L. So that is the meaning of limit of f of x as x goes to C. Let us try to understand using an example. So a straightforward example, let us consider a function f of x equal to x square. We would like to find the limit of the function f of x equal to x square as x goes to 2. For some of us, we know that if x is 2, then 2 square is 4, and supposedly the limit should be 4. Well, let us verify using the epsilon delta definition. Until and unless you do a couple of examples using and verify it using epsilon delta definition, won't be clear. So let us try to verify using epsilon delta definition. So let's say some epsilon positive is given to us. Our task is to show that x square minus 4, modulus of that. That means distance between x square and 4 should be less than epsilon. In other words, we want that mod of x minus 2, mod of x plus 2 should be less than epsilon. Or if x plus 2 is not 0, then we can probably divide by x plus 2 in order to get that x minus 2 mod of that should be less than epsilon over mod of x plus 2. So we write that 0 greater than mod of x minus 2, meaning that x is not equals to 2, is less than delta and less than epsilon by x plus 2. So roughly speaking, if we choose delta equals to epsilon by 4, we are done. Can we think about it for a moment? So hopefully you have thought and be sure about why you were done. If mod of x minus 2 is less than delta, that means x lies between 2 plus delta and 2 minus delta and 2 plus delta. In other words, x plus 2 lies between 4 minus delta and 4 plus delta. So when we divide We can divide epsilon instead of x plus 2 by 4, epsilon by 4, or epsilon by 4 plus delta. Now, would like to have under perspective of this definition. Note that x minus c mod of that is less than delta can be defined as the set and delta of c. That means neighborhood of c. And now the definition transforms that f of x belongs to the neighborhood of L or epsilon neighborhood of L whenever x belongs to delta neighborhood of C and x not equals to C. Let us try to understand with a picture. I've changed the material. Here you can see at the bottom the graph of the function f of x, and on the x-axis you can see point C and a corresponding value L on the y-axis. So from the picture itself, we can see that the functional value would lie in a narrow slit around L, which you can call as epsilon neighborhood of L x whenever x lies in the delta slit, delta neighborhood of C. We present the result in terms of a theorem. Let f is a function from A to R and let C be a cluster point of A. Then the following statements are equivalent: that limit of f of x equals L as x goes to C. The second statement, that given epsilon neighborhood of L, there exists a delta neighborhood of C such that if x is not equals to C is any point in the delta neighborhood of C as well as in the intersection A, then f of x belongs to the epsilon neighborhood of L. Now let us look at the same function as an example, but limit as C. We want to verify that limit of x squared equals to C using epsilon delta definition. Here f of x equal to x squared L equals to C squared given epsilon greater than 0. Mod of f of x minus L is simply x squared minus C squared equals x mod of x plus C x minus C. Now observe that mod of x plus C is less than equal to mod of x plus mod of C, which in turn is less than equal to 2 mod of C plus 1. And now f of x mod of f of x minus L, which we want to show be less than L, can be interpreted as mod of x squared minus C squared equals to mod of x plus C to mod of x minus C. Replace mod of x plus C by twice mod of C plus 1. And what we observe is that mod of x plus C to mod of x minus C is less than 2 into mod of C plus 1 into mod of x minus C. So if we choose x minus C mod is less than epsilon over 2 of mod of C plus 1, then what we obtain, that mod of f of x minus L, which is equals to mod of x squared minus C squared, would be less than epsilon.